Hi to everyone, I'm Alessandro and today I'll present the rationale behind the use of the FPGA in the project that me and Davide are working on for the Xilinx Open Hardware Contest 2017, and the name of the project is TiReX, a tiled regular expression matching architecture. Let's start with a brief recap about the context we are dealing with, which is regular expression matching. A regular expression, in a few words, is a sequence of characters or symbols that defines a specific set of strings to be matched in a stream of data. We commonly use regular expressions for the search of a particular string in a file. Differently from the most solutions that have been proposed in the literature that use the FSAs or finite state automata in order to recognize the regular expressions, our implementation is much different. We, in fact, aim at implementing a customized CPU with a specific ISA, or instruction set architecture, which differs from one regular expression to another one. The fact that each regular expression produces a different ISA implies the use of a highly flexible approach. Having this in mind, we can proceed with the analysis of the available technologies for the design of our architecture. We have identified 5 main metrics to evaluate the different technologies, which are performance, power consumption, cost, flexibility, and the design time. The first technology is the CPU. CPUs are highly inefficient for what regards the performances, but on the other hand, they have one of the most high degree of flexibility achievable. Secondly, we have the GPUs. Despite having one of the best values with respect to the performances, they have the great disadvantage of being power inefficient, and so they suffer from having high levels of power consumption. Then there are the ASICs, or application-specific integrated circuits. They offer the best consumption and performances levels achievable, but unfortunately they require a great amount of time in order to be designed, thus greatly increasing the costs, which could be cut down though by having a mass production of the devices. Another huge drawback of the ASIC implementation is the fact that it has no flexibility at all. Once produced, the device cannot be modified. Lastly, there are the FPGAs. We can have a quite high level of performance and a great power efficiency with the FPGAs, but the design times and costs using this technology are not negligible. For example, a Virtex 7 on a VC707 board costs up to $3,500. A strong point in favor of the FPGAs, though, is a high degree of flexibility. By analyzing the needs of our design, we have identified 2 KPIs, or key performance indicators, and one of these is the flexibility. We need an architecture able to be dynamically reconfigured in order to modify the ISA of a core in the tiled architecture, as previously said. This makes ASICs unsuitable for our design. Then we have performance over power consumption as the other KPI, and following the analysis, we saw that CPU have low level of performances and GPUs are highly power consuming, and so also they are not a reasonable choice for our project. That's why the technology that best meets our needs is the FPGA one, which more specifically will be a Virtex 7 mounted on a VC707 board. Thanks for the attention, and if you have questions, don't hesitate to ask.